Good morning, dear student. Today we start our third topic, laws of thermodynamics. So already we discussed in previous classes, we study about kinetic theory of gases, what is meant by heat, how to transfer heat, then conduction, convection, radiation, and so on. So now this class we discuss about laws of thermodynamics. So in this topic, first, we study about what is thermodynamics, what is thermodynamic system, then what are the types of thermodynamic system, then process of thermodynamic system, then four laws of thermodynamics, then derivation for laws of thermodynamics, applications, and so on. So one by one. Now let us start. What is thermodynamics? A thermodynamics in a physics is a branch that deals with heat, work, and temperature and their relation to energy, radiation, and physical properties of matter. So, what is thermodynamics? Thermodynamics is a branch of physics that deals with heat, work, and temperature and their relation to energy, radiation, and physical properties of matter. So, it is also explained another type. Thermodynamics is the study of interrelation between heat, work, and internal energy of a system and its interaction with its environment. The thermodynamics also status is the study of the interrelationship between heat, work, and internal energy of a system and its interrelation with its environment. So let us consider this a system is an environment, this is the whole system of the universe. So thermodynamics is a study of interrelationship between heat, work, and internal energy. So each atom or each molecules or each substance having some self-certain energy is the internal energy. In later classes, we study about what is internal energy of system and so on. So its interaction with its environment is known as thermodynamics. For example of the system is gas in container. Suppose in our domestic application we are bringing a gas cylinder. Anyone, you observe anything? Yes, yes, good, good, good. Now when I touch the cylinder is so cool because some temperature transfer between the system and the environment. Then another one is magnetization and demagnetization. Then charging and discharging of battery, chemical reaction, thermocouple operation. These are the some of the examples for a thermodynamics. So thermodynamics is the study of the interrelation between heat, work, and internal energy of the system and its interaction with its environment. Okay, very good. So next, thermodynamical system. A thermodynamical system is a specific portion of matter with a definite boundary on which our attention is focused. So thermodynamical system is nothing but a system is a specific portion of matter with a definite boundary on which our attention is focused. The system boundary may be real or imaginary, fixed or deformable. So you assume a thermodynamic system is nothing but in a container of gas. We consider a specific portion. So within the portion, we fix a boundary. The boundary may be real or imaginary. It is a fixed or deformable. So this is a thermodynamical system. So now, what are the three types of thermodynamic system? There are three types of dynamic system. One is isolated system, closed system, and open system. So there are three types of thermodynamic system. One is isolated, another one is closed, next one is open. So now we discuss one by one. First, what is an isolated system? An isolated system cannot exchange energy and mass with its surroundings. An isolated system cannot exchange energy and mass with its surroundings. The universe is considered an isolated system. The universe is considered as an isolated system. The next one is closed system. Across the boundary of the closed system, the transfer of energy takes place, but the transfer of mass does not take place. For example, refrigerator, compression of gas in the piston cylinder assembly are example for closed system. Like a gas cylinder. So the transfer of energy takes place, but the mass does not take place. This is a closed system. The third one, open system. In an open system, the mass and energy are transferred between the system and its surroundings. A STEM example is an open system. So, there are three types of thermodynamical system. An isolated system means there is no exchange of energy and mass. In closed system, only the energy is exchanged, but the mass does not change. But in open system, both mass and energy transfer between the system and its surroundings. Are you able to understand? So what is thermodynamical system? Thermodynamical system is nothing but a focus on a particular portion of the point. The transfer of energy or heat or mass within the boundary, we focus it. The boundary may be real or imaginary or fixed or deformable. So based on that, there are three types of thermodynamical system. One is isolated, closed and open. What is isolated system? A system there is no exchange of energy and mass with its surroundings. Example is universe. Next one, closed system. There is a transfer of energy, but there is no change in mass. In the first case, there is no transfer, there is no change in mass and energy with its surroundings. Second one can exchange the energy but not mass. In third system or open system, both mass and energy transfer between the system and its surroundings. So, based on that, there are four kinds of process in thermodynamics. There are four types of thermodynamic process. They have a unique properties. They are adiabatic process, isochoric process, isobaric process, and isothermal process. There are four process, thermodynamical process. One is adiabatic, isochoric, isobaric, and isothermal. So now we discuss one by one. First, adiabatic process. A process where no heat transfer into out of the system occurs. So that means there is no heat from the system or surrounding to the system. There is no exchange. There is no heat transfer between the system and its surroundings is known as adiabatic process. A process where no heat transfer into or out of the system occurs is known as adiabatic process. That means there is no heat or there is no energy transfer from the system or the universe to the system or the surrounding to the system is not possible. This process known as adiabatic process. In isochoric process is nothing but where no change in volume occurs and the system does no work. So I will explain later. So isochoric process is nothing but a process where no change in volume occurs and the system does no work. Then isobaric process, a process with no change in pressure occurs. In the previous one, volume, the second one, pressure. So it relates Boyle's law. Anyone state Boyle's law? At constant temperature, pressure is directly proportional to 1 by V or pressure is inversely proportional to volume. So based on that, here we consider isosteric process and isobaric process. Then the fourth one, isothermal process. A process in which no change in temperature occurs. Isothermal process is nothing but a process in which no change in temperature occurs. That means the heat transfer from the system or outside the system, from the system to the surroundings or surrounding to the system, but the temperature remains constant. This is the isothermal process. But in adiabatic process, there is no transfer of heat from the system and its surroundings. So based on that, there are four kinds of process: adiabatic process, isochoric process, isobaric process, and isothermal process. In adiabatic process, there is no exchange of heat to the surroundings and body. Here, there may be change, but the volume does not change, so the system does no work. In isobaric process, a process in which no change in pressure occurs. The isothermal process, a process in which no change in temperature, that means the temperature or heat transfer from the surroundings to the system or from the system to the surroundings, but we keep temperature remains constant. So this process is known as isothermal process. So this is a isothermal process. So you consider this piston, infill this. Now we are applying such amount of heat from the external surroundings to the system. So we know that the temperature is directly proportional to kinetic energy. So what will happen? The gas expand, so the piston move in upward direction. So some volume is increases, but the temperature remains constant. So we draw the graph between volume and pressure. So when pressure decreases, volume is increases. From the figure, initially high pressure. Due to the heat, the volumes increases but pressure is decreases. But the temperature remains constant at any point 1 and 2. This process is isothermal process. So similarly, I will explain isobaric process. In isobaric process, there is no change in volume, but that means there is no heat is done. So this is a isobar from the from 1 to 2, the volume changes V2 minus V1. Initially, we are applying some heat. Due to the heat, this changes, but the net work done is does not change, so there is no work. Then we draw the graph between volume and pressure. So P1 and P2, so volume does not change. Next one is isomeric process. So we can say system such amount of heat, what will happen? There is no change in volume, so there is no work will be done. So at a point 1 and 2, this is a isomeric process. Then adiabatic process. When adiabatic process nothing but there is no transfer of heat from the system and to the surroundings. So let us Q is equal to 0. Now due to the internal energy, already explained, I already told, we discussed in later the internal energy. So all the atoms are moving zigzag direction. You already studied about the kinetic theory of gases and also to derive the expression for the pressure. Very good. So due to this, the volume of the piston slightly move. So volume is changes automatically, pressure is changes, but there is no heat transfer from the surrounding to the system or system to the surrounding. So this process is known as adiabatic process. So there are four types of thermodynamical process: adiabatic process, isothermal process, isochoric process, and isobaric process. So next we study about laws of thermodynamics. The thermodynamics laws define the fundamental physical quantities like energy, temperature, and entropy that characterize thermodynamic system at thermal equilibrium. Thermodynamics laws define the fundamental physical quantity like energy, temperature, and entropy at thermal equilibrium. These thermodynamics laws represent how the quantities behave under various circumstances. So what is meant by thermal equilibrium? Thermal equilibrium means the temperature remains constant or we keep temperature must constant. A heat or the energy transfer from the system to the surroundings or surrounding to the system, we maintain the temperature remains constant. So that is called as thermal equilibrium. So now we discuss about laws of thermodynamics. There are four kinds of laws of thermodynamics. Zeroth laws of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. So first we study about zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two bodies are individually in equilibrium with a separate third body, then the first two bodies are also in thermal equilibrium with each other. So simply told, A is equal to B, B is equal to C, so A is equal to C. This is zeroth law of thermodynamics. The zeroth law of thermodynamics system states that if two bodies are individually in equilibrium with a separate third body, you consider three persons A, B, C. Now A and B are from the place, then B and C are the same place. Now we are both the three, one and two, one, two, and three are in our class. So this is an example for zeroth law of thermodynamics. So it states that the two bodies are individually in equilibrium with a separate third body. Then the first two bodies are also in thermal equilibrium with each other. Next, first law of thermodynamics. The first law of thermodynamics states that the quantity of heat or the amount of heat supplied to the system which is equal to sum of change in internal energy of the system and work done by the system. The first law of thermodynamics states that it is also known as the law of conservation of energy. What is law of conservation of energy? Energy can neither be created nor be destroyed. So similarly, the first law of thermodynamics states that when the quantity of heat or quantity of energy supplied to the system which is equal to sum of change in internal energy of the system and work done by the system. So change in work done by the system and so dq is equal to du plus dw we discuss in next. Before that, the second law of thermodynamics. The second law of thermodynamics states that the entropy is an isolated system always increases. An isolated system spontaneously evolves towards a thermal equilibrium. These are the two statements. The entropy of an isolated system always increases. Or any isolated system, the spontaneous evolves towards a thermal equilibrium, the state of the maximum entropy of the system. This is the second law of thermodynamics. The third law of thermodynamics states that the entropy of system approach a constant volume, obtain a constant temperature. So these are the laws of thermodynamics. So now we discuss zeroth law of thermodynamics. Let us consider a two systems A and B separated from each other by an adiabatic wall that contains no heat. So what is adiabatic? There is no transfer of heat and energy or transfer of heat and mass between the system and its surroundings. So the system A and B are separated by an adiabatic wall. So there is no heat contact between A and B. Let A and B in contact with a third system C through a diathermic wall which permits heat to pass or a isothermal wall. So A and B in contact with the third system C. So the isothermic wall is there. It permits heat to pass. AB separated by adiabatic wall, but A and B touch with C separated by isothermic wall. Then the system A will be in thermal equilibrium with the system C. Similarly, the system B will be in equilibrium with the system C. So A is equal to B, B is equal to C, so A is equal to C. So all the systems are in thermal equilibrium. This is a best law of thermodynamics, the zeroth law of thermodynamics. So now the adiabatic wall between A and B is replaced by a isothermal wall. We find experimentally that no further change happens at A and B because already A and B are touched with this, so they are in thermal equilibrium position. So it concludes that if two systems are in thermal equilibrium separately with a third system, then they must be in thermal equilibrium with each other. This is a zeroth law of thermodynamics. If two systems are in thermal equilibrium separated with a third system, then they must be in thermal equilibrium with each other. This is a statement of zeroth law of thermodynamics. So next, all the system in the above cases can be set to process properties known as a thermal equilibrium. This property is known as a temperature. We may define the temperature and heat in previous classes, so I need not explain once again. So, the significance of zeroth law of thermodynamics is if a number of systems are in thermal equilibrium, the common property of the system can be represented by a single numerical value and it is called temperature of the system. So, next, first law of thermodynamics. The first law of thermodynamics states that the amount of heat supplied to the system, which is numerically equal to sum of change in internal energy of the system and work done by the system. Let us consider a cylinder. Now we give some amount of heat. Such amount of heat added, such amount of heat removed. That means we are applying some amount of heat. Due to that heat, initially the internal energy of the system is increases. Due to that, the system is expand. Some work will be there. So the amount of heat supplied to the system, which is equal to sum of change in internal energy of the system and work done by the system. So this is called as first law of thermodynamics. When heat energy supplied to the system, we explain mathematically. A dq equal to du plus dw. It is a mathematical expression for the first law of thermodynamics. So a quantity of heat supplied to the system which is equal to change in internal energy and work done by the system. So the significance of first law of thermodynamics is it shows the exact relationship between heat and work. Whenever there is a transformation of energy from one form into another form, the total energy of the system remains constant. So dq is equal to du plus dw. So now the applications. So thermal changes dq is equal to p into dv. Then adiabatic changes. So adiabatic means there is no change in system. So d0 du plus dw dot dq. So the work done is equal to change in internal energy of the system. Because adiabatic process there is no heat is allowed or removed from the system. The internal energy decreases, the temperature of the system falls. So dw is equal to minus d into u. So similarly, a blowing of bubble. Let a bubble blown as a dA, the total increase in the area of the bubble. So work done sigma into dA. So total work done is equal to F dot S. Similarly, minus sigma into dA. So finally, we get dq value is negative. The bubble gives out of heat to the surroundings to maintain its temperature remains constant. So in this class, we discuss What is thermodynamics? What are the four type of process thermodynamical system? What are the system? Adiabatic, isobaric, isochoric, and isothermal. This is system? No, 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 no. There are three type of system. Is a adiabatic system, closed system, and open system. Isolated. Good, good. So there are four type of thermodynamic process. Is a adiabatic process, isothermal process, isobaric, and isochoric. And there are four kinds of laws of thermodynamics: zeroth law, first law, second law, and third law. So in later classes, in the next class, we detailed study about the second law of thermodynamics and applications. We discuss about Carnot engine and efficiency of Carnot engine and heat engine and so on. Then third law of thermodynamics also. Then to derive the maximum thermodynamic relation and everything goes to in continuous classes. Okay. Thank you. Thank you for listening. Thank you, students. Thank you. Have a nice day.